Hello, Professor and classmates. My name is Lucas Stump, and my project partner is Ralph Etienne, and today we will be presenting our final project. And we chose to do something we called the Dog Whisperer, which is a sensor that is used to control our dog's behavior. So let's get right into it. Um, a main objective of ours was to create a sensor that could help control people's pets, mainly dogs, because as you know, they could be very loud, sometimes obnoxious, and not just disturb us, but our neighbors with their noise and their barking. So, using a big sound sensor and a voice recording module, we can command our dogs to stop barking. Dogs naturally bark when an animal or human approaches their territory or home, and sometimes, as I said, it can be excessive and a nuisance. As their owner, we have different commands to tell them to stop what they're doing, and in our example we use stop or sit. So by making a device that can repeat these commands with our voice when we are not home or in the same room as them, we can control their barking so they won't disturb our neighbors, us, and just kind of makes it more efficient, and it's going to be really helpful. Some of the components required to make this project was a big sound sensor. We needed a sound playback sensor with a speaker, an Arduino Uno with the cable, jumper wire cables, preferably male to female, a breadboard, and a soldering kit because one of the sensors needed to be soldered for them to be joined and work together. Next, we move on to the procedures. We connect the Arduino Uno board to the breadboard by connecting the 5-volt terminal to the positive row on the breadboard, in our case the red jumper wire. We then connect the ground terminal, or as it is labeled on the board, GND, to the negative row on the breadboard, the brown jumper wire. We then assemble the voice recorder module, the ISD1820. This recording module is has a small voice recorder and playback module on it that can do multi-segment recording. The user can achieve high quality of recording from up to 8 to 20 seconds for each application with the adjustment on the onboard resistor. This voice recorder / playback module is designed with an embedded flash memory which can hold data for up to 100 years and erase / record the life cycle up to 100,000. So, our speaker was not wired, so we needed to solder the wires to the speaker. The speaker has a negative and a positive input. Next, after the wire was soldered to the speaker, we then connected the speaker to the voice recorder on the terminal labeled SP1. From the module, we connected the voltage terminal, or the 5-volt terminal row on the breadboard with the jumper wire. Then, from the module, we connected the ground terminal to the ground terminal row on the breadboard, the white jumper wire. From the module, we connect the playback edge activated terminal, or PE, to digital input 5 on the Arduino board, the red jumper wire. We assemble the big sound module by connecting the power terminal of the big sound module to the 5-volt row on the breadboard. Then we connected the ground terminal of the module to the ground terminal row on the breadboard, using the gray for the positive and green jumper wire for the negative. Next, we connect the digital output, or DO, of the sound module to the digital input 3 terminal on the Arduino board, the orange jumper wire. We then power the Arduino board by connecting it to our laptop via the USB cord. Once connected to our laptop, the Arduino board, the big sound sensor, and the voice recorder were all powered via connections through the breadboard. So the breadboard was providing all the current for every device that was connected to it. After the hardware was all connected and complete, we then moved on to the software, where we needed to program our device for it to work. So, as you can see in the picture of the code, so from the code, playback E is a variable on terminal 5. The voice recorder acts as the output. When the sensor receives the high signal, the voice message is played until it ends and stops. The sound sensor is a variable on terminal 3. The sound sensor acts as the input. When the sensor is excited with the sound, it generates a signal to the voice recorder, which triggers a message to be played that can be heard on the speaker. This code is then uploaded to the Arduino board. Our next step is to record a message with our voice onto the voice recorder by pressing the red REC button on the module. When we are done recording the message, the button is released. The message is now stored on the recorder. On the big sound sensor, we could adjust the sensitivity of the sensor by rotating the potentiometer dial. In the picture, you see it's the golden screw with the flat head shape that could be turned. So if we wanted to increase the sensitivity, we would rotate it clockwise, and to decrease the sensitivity, we would rotate it counterclockwise. Conclusion. After powering the circuit, we are proud to say that our project was a success. When a noticeable sound was made, in proximity to the sound module, the sound would trigger the voice recorder to play the pre-recorded message, commanding our dog to sit or stop barking. Following the experiment, there were a few modifications made to improve the project. The speaker was only worked on 8 ohm and 0.5 watts, so the sound was very low. To improve the sound, we put the speaker in a box enclosure. This provided a much deeper sound. We also transferred all the components of the project within the box enclosure in order to make the device more portable. We purchased a 5 VDC adapter that would be plugged in to an outlet and power the device. The sound module was mounted outside the box with the speaker for obvious reasons, and the voice recorder and Arduino board were mounted within the box. A small opening was created to allow access for the power supply and for the Arduino board. The average cost of our project was around $5. So, as you can see, it's a simple yet very effective device that could help many people, just with their day-to-day lives. A little backstory as to why the project that we had pitched originally and sent to the professor changed. Our original idea was to create an intrusion device that would pick up either motion or sound and allow the user to know by a message being sent to them. The reason why we changed was, after brainstorming a bit more, we discovered that there are a lot of devices that already do that today, and why just make another one if there are better ones out there? So with our intrusion device that we had originally thought of, we said, you know what? Let's kind of think of something different along the same lines. So we then came up with the idea to use the sound sensor to help users who own dogs keep the noise level down in their house when they're away. Hence, the Dog Whisperer, our project. So as always, there are certain aspects of projects that could always be improved after they are completed. So I'm going to name a couple that we thought, if we were to work on this project some more with some more time and more resources, that we could have improved. So first and foremost, the sound quality. The sound quality is decent, but if we were to find a speaker or had purchased a speaker that could produce a louder noise, it would have been more efficient. So that way we make sure our dog actually hears our voice recording. Doesn't think it's something else or whatnot. Another aspect that could have been improved is to program the device to only activate when a dog barks and not have other loud sounds activated. And last but not least, the size of the device. If we could find a way to condense the size and make it more discreet, I think it would be much more approved with users and more liked. Make it less of an eyesore, so to say. And so that way they can place this device around different parts of the house and it doesn't stick out. So overall, my partner and I were very proud of what we achieved. And now we will show you video clips of our project at work. And also in some of these video clips you'll see what exactly we needed to adjust, how we wired certain things, and then you get to see my partner's dog Zeke help us show you this demonstration. I hope you enjoy it. Here is the ending result of our project. As you can see, the box enclosure that we put everything in. The black circle on top is the speaker, and then the big sound module sensor is the red one on the side, and then the first picture with it open you can see is the breadboard and the Arduino board inside to kind of make it look better, more feng shui. But so yeah, in the future I think we can definitely design something that looks a little better, but that's our ending result. In this clip, you can see us adjusting the sensitivity on the big sound module by turning the screw. You'll see how when it is turned clockwise, the sensitivity is increased, and counterclockwise it is decreased. And you get to hear my partner's voice recording through the speaker. So there you go.
Sit down.
In this final clip, you will be able to see our device at work and as you'll notice, it is plugged in to an outlet, so that is how it's powered. And then you'll be able to see our little helper Zeke demonstrate to you how it works. Hope you enjoy it.